Okay, and I've gotten 3 questions so far off of section 2.6, 33, 36, and 39. They're all actually pretty similar in the conceptual way that we solve those problems, so I think we're going to be able to knock all 3 out here in one video. So starting on number 33, we've got a limit as theta is approaching 0 of the sine of 7 theta over the sine of 3 theta. First thing we should always try is plug and chug, but not surprisingly we get sine of 0, which is 0, divided by the sine of 0, which is 0, and 0 over 0 means obviously we have a problem there and we can't do direct evaluation. So what we need to work on now is a basic concept that I need to make sure that everybody understands. We are not going to be able to get rid of this 7 or to get rid of that 3. Those coefficients, those b values, are stuck there in front of the theta. So the only way around it is to make the opposite side of the fraction then have the same factor as this angle here in the numerator. In the numerator, we are taking the sine of 7 theta. So what we need to do is put a factor of 7 theta down here in the denominator so that eventually those will work together. Now I can't do that unless I also multiply the numerator by 7 theta as well. Now the exact same thing is happening here with the denominator, and this is something we didn't talk about in our notes, so I'm glad it came up in a homework question. To deal, let me say, with that sine of 3 theta in the denominator, we need to put a factor of 3 theta up here in the numerator, and of course then we need to do the exact same thing in the denominator as well. So where are we here now, guys? This is a little bit messy, but it's going to work for us. We are taking now the limit as theta is approaching 0 of, and let me just kind of selectively put some things together right here. I've got a sine of 7 theta in the numerator, and in the denominator I also have a factor right here of 7 theta. So I'm going to put those two together in one fraction. I also, let's take a look now, in the denominator have a factor of the sine of 3 theta. And to go along with that, we have a factor of 3 theta that's going to go above it. So let's see, I've taken care of this, and this, and this, and that. The only things we haven't dealt with yet are a 7 theta up on top and a 3 theta down on bottom that we had to put there just to balance everything out. Now the very first thing I want you guys to notice is that last factor of 7 theta over 3 theta already has an identical factor of theta, so we can just cancel those out. And now, well, actually I think we're in pretty good shape here, guys. What we're going to do now is use the product property for limits that says that the limit of a product is equal to the product of their limits. Again, I hate to say it because it's not right, but it's kind of like we're distributing this operation of a limit to each of those 3 factors, even though it's not actually distribution. But anyway, here we go. So the limit as theta approaches 0 of sine of any angle divided by that angle itself, well, that limit is always going to be 1, regardless of the value of the angle right here, as long as you've got the same factor down on the bottom. Now the second limit, this one right over here, this is the one we hadn't really talked about before. Instead of having sine of an angle over an angle, which is what we had in the first case, now we've got the reciprocal of that. Well, as you might have guessed, this limit is going to be the reciprocal of what the limit would have been if it were sine of 3 theta over 3 theta. That limit would have been 1, so we need the reciprocal of 1, which, lucky for us, is 1 also. And the final limit right here, the limit as theta approaches 0 of 7/3, the limit of a constant, everybody, is always the constant itself. So that limit is just 7/3, and we would multiply all 3 of these limits together and get 7/3 for our final answer. Now, if we were to go all the way back to the original problem, which was right here, there you go, I want to reiterate something that I said in the notes on section 2.6. It's going to be really easy, especially if you go back and look at things in hindsight, everybody, to come up with the right answer for the wrong reason. A lot of people are going to look at that original problem and just say, oh, I can just pull the 7 out in front and pull the 3 out here. Those end up wiping each other out, and I just end up with 7/3. All I can tell you here, guys, is once again, that solution, or that way of obtaining the solution, is based on faulty mathematical reasoning, and it's the kind of thing I will be checking your work for, and you will not be getting much credit. The AP graders wouldn't give it to you either if you happen to get the right answer with reasoning that wasn't solid. Okay, so that was number 33. Now, 36 and 39 work in a similar manner. Let's see what's going on. Big difference in 36 is that we start off with a tangent on the top, and then something weird that really should never be. And that is a secant down in the denominator of a fraction. We'll talk about that in just a second. So let's see what we can do. Dang it, my hand is getting in the way of things again. Okay, so the limit as t approaches 0 of, and let's see what we can do. We did a problem in notes telling you what to do with tangent of any angle. You always split it into sine of the same angle divided by cosine of the same angle. So this is going to become the sine of 4t divided by the cosine of 4t as well. Please make sure you're including the angle because this is big kid math and we care about that level of precision here. Tangent of 4t becomes sine of 4t over cosine of 4t. Now the thing you should really never see, everybody, is one of your reciprocal trigonometric identities, cosecant, secant, or cotangent, down in the denominator of a fraction. It just doesn't make any sense. A secant in the denominator is exactly the same thing as multiplying by a cosine in the numerator. So that secant on the bottom, I'm going to move up and make a cosine, and the angle does not change. See, I think that's important because I wouldn't be shocked if somebody tried to cancel this cosine and this cosine right here, but because the angles are not the same, those cosines do not cancel out. So that's a really important distinction to make. And the only thing we haven't talked about yet is this factor of t located down in the denominator. Well, there's nothing we can do with that, so that t is going to stay anywhere we want to put it, really, down in the denominator itself. All right, so let's see where we're at. A lot of people look at this and see multiple problems with it. There's a couple things here that really don't bother me. The cosine 4t in the denominator and the cosine of t on the top are not problematic as t is approaching 0. Because let's remember, guys, in both cases, your angle is going to approach 0, and the cosine of 0 is not 0, it's 1. So those aren't a problem at all. The only real issue here is the sine of 4t located in the numerator. So if my angle is 4t, which it is, and I can't change it, which I can't, my only option is to introduce a factor of 4, which I will put together with that t right there in the denominator to make a 4t. And I can do that as long as I also multiply the top by 4 as well. And I think at this point we're going to be home free. Let's take a look. So that is the limit as t approaches 0 of, and let's see what we've got. I'll go ahead and make a whole mess out of this. We have got a sine of 4t in the numerator. That's done. And now I put these two together and make a 4t in the denominator that goes right underneath it. What else? In the numerator, we have a cosine of t. We have a factor of 4, and then it looks like we also have a cosine of 4t down in the denominator. So now again, I'm going to apply that property that says that the limit of a product is just the product of the individual limits. And in my head, at least anyway, guys, I'm going to lump these guys together. The limit as t approaches 0 of sine of any angle divided by the angle itself is 1. So I'll start with a 1 right here. We're going to multiply that by, let's take a look now. As t approaches 0, the cosine of t is 1. We multiply that by 4. We get a 4 on the top. And down on the bottom, the cosine of 0 becomes 1 as well. So it sure looks like, and sorry guys, I'm out of space here, sure looks like this answer is going to be 1 times 4, which is just going to get us the correct answer of 4 here for problem number 36. And last one for now, let's take a look at problem 39. This one is actually a little bit more like 33, which we saw just a second ago. You know what? Save myself a little room. I'm going to move that up there. Okay, so here we go, guys. Now, once again, if you've been paying attention to the last two problems, I think you now know what to do here. We've got coefficients in front of our thetas, a -3 on top, a 4 on bottom, that cannot be gotten rid of. So they need to stay there. There's my hand hitting my iPad again. So still, the limit as theta approaches 0 of, but let's try to break this up. We've got a sine of a negative 3 theta up here on top. Okay, the only way to deal with that is if we also put a factor of negative 3 theta on the bottom. So, I guess I'll do this in red here on that spot. I can go ahead and put in a factor of negative 3 theta on the bottom as long as we also, I probably should have extended that already, as long as we also put the same factor of negative 3 theta up here on the top. Okay, moving right along. We also have a factor on the bottom that's problematic of the sine of 4 theta in the denominator. And the only way to deal with that is if we introduce a factor of 4 theta up here in the numerator, but then we'll have to put a 4 theta down here in the denominator as well. So what hopefully you're seeing in blue there matches the original problem right up here, and in red, everything that we've done here, we've done the same thing on the top and the bottom, so we're in pretty good shape. And now, well, I guess I did this in a decent order right here, because now we can evaluate this limit right here times this limit right here times this limit right here, and I don't think this is going to be all that bad. So the limit, as theta approaches 0, of sine of any angle divided by the same angle is always 1. As we go to do the second limit, now it's just the reciprocal of that. It's sine of an angle on the bottom, the same angle on the top, so this limit would be the reciprocal of 1, which is also 1. And then the thetas in these last two terms are going to cancel out here, and that's going to give us a limit now of negative 3/4. So the 1 times negative 3/4 is going to get us our correct answer here of negative 3/4. So hopefully you guys have seen the similarities in those themes there in 33, 36, and 39, because we are likely to see problems like that show up again in the future.